I was just reading an article yesterday on the theory of gravity described in terms of electrodynamic theory, and it's the first time that somebody has presented a gravitational theory in terms of electrodynamic theory that I could actually comprehend, and so I give it a thumbs up. It essentially states that we misname gravity in as much as it's actually electrostatic cling, saran wrap cling. And this makes perfect sense that it's a charge state, because I've always held that, well, not always, but recently, that the hollowness of planets has everything to do with this sort of thing, inasmuch as the interior hollowness of a planet, or the sun, which is also a planet, is not entirely hollow because there's something at the core. And I've held that it's not something material so much as something energetic, more than likely. But it makes sense because that means that another thing I've held is that the property of buoyancy is at stake here. And that property of buoyancy is what determines the diameter of this hollow shell. Namely, if the buoyancy had been any different, the diameter would be different. So the shell is finding its happy medium as to how far away from the center it wants to position itself. Not too much, not too little. And this is perfect because it could be easily explained in terms of electrostatic charge, which is causing the shell and the core to separate from each other so much, but no more, and no less. A charge state, they said a Coulomb state. They quoted something, a huge figure, I don't know, it was either 60 or 50 million or 1,000 coulombs charge is being involved or invoked. And then all the objects on the surface are attracted to that charge. This is why, a very good reason why, I'm supposing that the core is not matter, because matter will always acquire the same charge. Let's see. In order for matter to always be attracted to matter to a certain degree, it would have to all be of the same charge. Let's see if I got this right, though. No, wait a minute. I thought it's the same as electromagnetic charge. Well, with electromagnetic, opposites attract. Which, of course, when we're dealing with electrostatics, we can't say opposite, we have to say similar. I mean, there's no such thing as opposite, it's just different states of charge. Well, let's see. When Eric described the dielectric, he said that it wants to pull the plates together. That's right. He did say that. But the plates are different in charge. have a difference of charge. And if they pull themselves together sufficiently, they will even bore a hole through the dielectric if they can, which ultimately equalizes charge. So actually what that implies then is that gravity is based on differences of charge. While anti-gravity would be a similarity of charge, you would think. A similarity of charge creating anti-gravity. Well, let's go back to the Searle effect, the original one, not the one that's currently promoted by Searle himself, which is based on electromagnetics, but what Joseph Cater describes to us in his book, that the original experiment in the 1950s, around thereabouts, was an electrostatic experiment in which they took a wooden frame and covered it with aluminum foil, spun it with a regular gasoline motor, and when it reached a certain speed, it started to take off. And it started to self-induce its own speed, or self-induce its own acceleration, even though it was disconnected from the gasoline spinning artifice. So here we have spin rate induces a charge. And also not just only spin rate, but also the breadth and the hollowness. So it actually required a hollowness and versus a certain spin rate to counterbalance its mass in order to change its electrostatic state to be different sufficiently enough to repel the Earth. That makes no sense. Oh dear. Yeah, but it's a spin. Yeah, spin may not be the same. What would be different about it? So here, the capacitor plate analogy breaks down, because it's not a simple arrangement of two plates. It's more like two gyroscopes. And we know that a gyroscope loses weight. We know this. It may be inducing an electrostatic field, but why? Okay, so it's different. It's not the same as a capacitor. It's not a good a capacitor is not an appropriate analogy. That's why nobody figures it out. And that's why nobody figures out the Wimshurst, or the worst of all, the Testotica, because there's spin involved, a spinning electrostatic field. Yeah, we don't understand spinning electrostatic fields. We're not taught this, and it's not evident in our circuit, and we don't have a component to exhibit this, to be placed in the circuit. What if the LMD module of Eric Dollard amounts to nothing more than a rotating electrostatic field? Something that would not be possible otherwise by a single component, because we don't have one. Nobody puts a gyroscope in a circuit to change the behavior of that circuit. But we know a coil is twirled, so it's already inducing a spin of some kind, either electromagnetic or electrostatic, within the current that traverses through the coil. Ooh. Didn't I say there were two types of escalation? One in which the coil dominates the circuit and the other, the LMD module, versus the capacitor dominating? So if the capacitor dominates its unidirectional DC impulses, which would be discharged from the Searle effect, from the Searle effect device, the spinning hollow aluminum foil disc. The funny thing is, though, that the Searle effect does not alternate direction. So that means that the LMD module is alternately exhibiting gravity versus anti-gravity, because it keeps... Well, no, wait a minute. No, it does not have to change the rotation orientation on each half of the LMD module. In fact, it can maintain it, because when the energy reverses direction, that's sufficient. That's right. That's sufficient. It'll look like it's reversing its spin, but the geometry of the spin remains the same. It's merely the direction that changes, which does not change the spin orientation, because I'm thinking in terms of winding a toroid. There are two different ways to wind it, clockwise versus counterclockwise, and it doesn't matter which way the electricity moves, it'll still be the same winding, but it can still move either forwards or backwards. So good grief, that means that gravity versus anti-gravity does not alternate on one half of an LMD module. Now, I've never checked. I've actually the coil winding I've used when constructing an LMD is always the same winding direction on both halves. I've always used the same, so it almost then does not matter whether or not it creates gravity or anti-gravity, just so long as it creates it and reverses direction, or at least attempts to. Yeah, it either reverses direction and completes itself as a wave, which is the coil dominating, or else it becomes chopped off and never gets to complete its wave direction, which means the capacitors are dominating. That's interesting. So what would happen? See, we can't... Oh, wait a minute. No, yeah. In a transformer, you can swap the coils. In Paul Falstad simulator, you can swap the direction of the two coils. So, but that tends to create friction of a type which tends to eat up the energy level. So it's usually best that the coils always have the same direction of winding. Which would imply that a daisy chain is gravitational, because they all have the same winding direction. So they're going to have the same orientation of spin, which means they're going to cling. So in actuality, it is an electrostatic cling, but it's not static. It's rotational. And the gravity versus anti-gravity has to do with the spin direction, not the charge difference. The charge difference is just the magnitude of the gravity versus, or the magnitude of the anti-gravity, because it's an absolute value, but it does not take into consideration the spin direction. And the spin direction is toroidal. It's not a radial disk. It's a toroidally shaped spin. I'll be darned. This is a whole nother vista for understanding electrostatics, and why we don't understand gravity, or levity for that matter. That's interesting. This is interesting. So, that means that the core of a planet, the toroidal spin has to be the opposite of the material at the core, or the energy at the core. And that's probably why it's energy, because it's probably what we would call antimatter. What we call antimatter is simply an electrostatic oppositional spin. But matter apparently always exhibits the same toroidal spin direction, whether it's clockwise or counterclockwise, or else there wouldn't be gravity exhibited between distant objects of matter. It would have to be all the same. And thus the core, having the opposite, keeps the shell buoyant, keeps it repelled from the center, the geometric center of the Earth, with a certain force sufficient to get it to repel, because otherwise it would collapse into a solid object. And it's not solid. So it has this repelling force to create the hollowness, the hollow geometry. So it's this oppositional spin, toroidally shaped electrostatic spin, that creates the hollowness. I guess that's about all that can be said at the moment, because it's really simple and straightforward. Maybe not. No, maybe there is something more that can be said. Mendeleev, who designed the periodic chart, left out two elements that he called X and Y, because he was afraid we would not be able to accept his chart with X and Y included, and they are pre-hydrogen elements. What if one or both spin in the direction opposite to everything else, beginning with hydrogen on up? That would be an intriguing possibility. Or the distinction between the X and Y isn't so much direction, because each may be opposite in their direction anyway with respect to each other. It may be that the nature of the X and Y material can never coalesce as matter. It always has to maintain itself as energy, which would mean that the core needs the shell just as much as the shell needs the core, because without the shell, the core would explode. It would not adhere into a core geometric shape, just as the shell would not adhere into a shell's geometric shape. So there's something else going on. Than just geometry of spin, electrostatic spin. Unless, oh dear, this gets goofy. What if, let's just take, as a guess, or, an arbitrary selection. It has nothing to do with guessing. Let's just say X is pure magnetism, and the Y element, pre-hydrogen element, is pure electrostatics. In other words, electrostatics and electromagnetics are matter. They are a distinct particle, not merely a type of wave. The wave is just the field effect that surrounds the particle, but the particle is still a particle. That means that X and Y travels through a circuit without changing the circuit. It's literally transparent to hydrogen on up, which is why we never see it. All we can do is infer them. In fact, without them, hydrogen on up would not exist, because hydrogen on up is constructed of X and Y. And usually in a balanced state. That might be the role of the neutron, the so-called neutron, which means there's a third type of particle, not just X and Y. We'll call it Z. And that third particle creates matter as we know it, but without Z, we would simply have magnetism alone or electrostatics alone. That means that hydrogen on up is electrical in nature, while the pre-hydrogen X and Y are not. Which begs the question, where does Z come from? If we don't have it at centers of hollow planets and hollow stars and hollow elliptical galaxies and spiral galaxies, then where is it? What if neutrons are nothing more than the subdivision of space? What would normally be called ether, because if you go into the 1800s Sanskrit English dictionary translation of Akasha, we find it translates into the word ether. But when we look at the 1900s variety of Sanskrit English dictionary, Akasha translates as the word space. They dropped ether and replaced it with space. To lend this notion that space is hollow, basically. And in a sense it is, because it can take on either characteristic. I think the difference is the subdividing nature, or the subdividable nature of the ether, which creates the neutron only when it's been subdivided into individual units. But held in conjunction, though, or interacting in conjunction. So that means the electron is the electrostatic, let's say it's Y, and the proton is the electromagnetic X. And the neutron is the ether, which would mean it's like a bubble, an individual shell of its own. In fact, the X and Y might be bubbles also. The bubble geometry might be very intrinsic to all of this. So why would we have a particle that's not electromagnetic, that's not electrostatic, that's not accounted for? Because it's neither, but that's somehow not good enough. Eric Dollard never talks about it. He says time is the third element. So if the nature of the neutron is simply time, irrespective of any electromagnetic or electrostatic charge, then that would be the third element, is time, which is a particle. That gets a little heady, because that means that a neutron by itself is timelessness, which is what the ether constitutes. The timeless state of matter is the ether. That would define the ether as the timeless state of matter, while pre-hydrogen X is electromagnetics and pre-hydrogen Y is electrostatics. Oh, that gets really goofy. Now it's no small wonder that you can have electricity traveling forwards or backwards in time, because it's simply a behavioral characteristic of freedom, 2 degrees of freedom, of a behavioral characteristic of the neutron. Not of the proton or the electron. So we can't have electricity with the electron. And electromagnetic theory states that that's where current comes from, is an electron being bumped off of one atom and transferred through empty space via a photon to the next atom. But that would have to be erroneous, because it's merely an electrostatic charge particle that could possibly get transferred, and has nothing to do with electricity exclusively, because electricity is more complicated than just electrostatic charge. And the electron does define do they call it electrovalence? I think so. No, electron volts. Right, the electron defines electron volts, which is not electricity in and of itself. The volts have to move, but you can't get electrostatics to move in and of itself, because intrinsic in the word static means it stays put. Well, magnetism is always in motion and never stays put. So there you go. That's why the proton is at the center, because it's not moving, while the electron is in the shell because it's moving. Wait a minute. No, that's backwards. Whoops. That means the proton is electrostatics, the clinging effect, right? While the electron is electromagnetism, pure movement. Okay, so that would jibe with the theory, the conventional wisdom theory, that electrons do get bumped off and they move, because that's all they ever do is move anyway. But they do not. But see, that would contradict their definition as electron volts, determining electron volts of an atom. Yeah, there's some discrepancy. This is going to take some more thinking. But I like it because it means that from hydrogen on up, the ether actually figures into the equation as the neutron. And magnetism figures into the equation as a pre-hydrogen X, let's say, might be the Y, and the other one, if not one X, if not the X, then the Y, if not the Y, then the X, then the other one is electrostatics. Yeah, this is going to take some thinking. It could be that the model of the atom is incorrect, but because if electrostatic cling is involved, that would mean the proton would have to be exhibiting the electrostatics, not the electron. And that means that the electron volts of the electron does not come from the electron itself, but in conjunction with its interrelationship, its behavioral interrelationship with the proton. Because the electron would have to be pure magnetism. So we don't see it, we don't know it as electricity except for the fact that the proton is involved. That's right. The synthesis of electricity is the combination of both magnetism and electrostatics. But that's not the way we define the electron. We specifically say it determines electron volts. What would that mean? That means that the proton fuels the movement of the electron. In its interaction, which could imply that electromagnetism in its pure state does not move, if not for... Oh, this is beginning to get weird. I'm going to have to break off. Sorry. I've done enough extrapolating that I can do. This is getting to be complicated because it's the interaction now that's starting to look weird or interesting, or take it as you wish, however you want. Yeah, the atom model may be flawed. I don't know. If all protons do is cling, then that has to be the electrostatic. While the electron never clings, it just keeps moving. That would have to be the magnetic, the electromagnetic. Oh, yeah, this is too weird. I can't resolve this. Okay.